in this video we will learn about the method of substitution. Method of substitution means we have to substitute so that we can find the different order. Now you know the some of the examples. Okay, so this is method of substitution, and now we have d by dx of x to the power n as nx to the power n minus 1. So this is formula which you know. So d by dx of x to the power n over d by dx of x to the power n is nx to the power n minus 1. Suppose you are given to find differentiation of ax plus b whole square or whole to the power 100, or for first case I take it as whole square. Then what you do, you are free to expand this, so you can write y as a square x square plus 2abx plus b square. This is just a plus b whole square. Using this formula I have just expanded this. Now since I have to differentiate with respect to x only, so this x square is function, this is function, and rest a and b are just constants. So when you have to find dy by dx, then you take a square outside, just you write d by dx over x square, because a square is constant. Same way 2ab is also a constant, so just write 2ab d by dx of x plus this is eventually a constant function, this is b square. Now you know that a square as it is, because this is a constant, and the d by dx of x to the power n is 2x to the power 2 minus 1, that is 2x. So this is 2x plus 2ab. Differentiation of x. Differentiation of x is x to the power 1. You can take it like that, and this become 1 and 1 minus 1. So this is 1x to the power 0, and we know that by the rules of indices any number to the power 0 is 1. So differentiation of x is just 1 and differentiation of constant is 0. So d by dx will be dy by dx in this case will be 2a square x plus 2ab. Now since we have expanded this, because we know the formula somewhere, even if I write 5, then using the binomial expansion you can expand it, but you will get 6 terms and their values will be some random numbers like 5c0, just like 5c0 a to the power 5 x to the power 5 plus 5c1 a4 x4 and then b coming one time, like that. So you can expand this binomially and then you can differentiate each and every term, but that is just difficulties. Now if I have this as 100, then you use the binomial terms, and then on expansion you find there are 101 terms, which is ridiculously difficult to differentiate such a term. Then comes the method of substitution. How? Just look at this term. First let me clear the screen first. Then so now see d by dx of x to the power n and d by dx of something to the power n, but this is x and this is something. That there you need to differentiate, because if you see properly it looks like this one can be substituted properly, then it will take the form of this. Now how? So I say let ax plus b is just t, another variable. So this one becomes y is t to the power 100. This is resembling very much like this. Then you differentiate, but now you have to pay attention to this. Y was the function of x, y was the function of x, and now you are finding dy by dx. Now you have substituted ax plus b as t, so now the y has become a function of t. So by substitution y has become function of t and the t is a function of x. So it means y is related to t and the t is related to x just after this substitution. And since we have to differentiate this function with respect to x, then we'll write dy over dx as d by dx of t to the power 100. Now this d by dx, so you have to differentiate a function of t with respect to the function of x, like with respect to x, which is impossible. So you have to change the order of differentiation by, like d by dx, if I say I make it d by dt, and then there I write dt over dx. So if you see properly, I differentiate y with respect to t and then t with respect to x. So we are just having a chain, and it's called the chain method. So dy by dt, this is dy by dt into dt over dx. So dt cancel, and then you are having this dy over dx. Now I write the values of y and t respectively. So d by dt, what is t? That is t to the power 100, because y is, this is y and y is related to t like this, and then this is d by dx, and then at the place of t you can write ax plus b. So this will become 100 t to the power 99. Using this formula, 100 comes here, and then 100 minus 1 is 99. And then if you differentiate ax plus b, so you see here ax plus b, a is constant and differentiation of x is 1, plus differentiation of constant b is 0. So it's a plus 0, that is a. So this is a. Now you just write the whole term properly, then you get a 100a, right? 100a, and then here you have ax plus b whole to the power 99. This is dy by dx. This is method of substitution. Now I'll take another example to explain the ideas of the method of substitution. Now this time, suppose you know that there is a formula of d by dx of tan x is sec square x. This is the formula. This you know that. Then how have we found this formula? By method of ab initio or the first principle. Now if you are asked to find the differentiation of tan to the power 5 ax square plus b. This is what we have to find. Like 10 to the power 5 and ax square. So now this is neither 10x properly, nor this is x to the power n. But I can write this as y as tan ax square plus b whole to the power 5. This is same thing. Now the first substitution we need to make, that we substitute this whole thing, whatever inside this curly bracket, as something. So this will become y equal to that something to the power 5. So suppose if I write y equal to t to the power 5, what does it mean? Means I have assumed t as tan ax square plus b. So now y has become t. So y, which was the function of x, has become function of t, and the t is the function of x. So we got a chain, that is y is related to t and then t is related to x. So we do not have the direct relation from y to t after this substitution. So we'll use the chain. So we'll find dy by dt and then dt over dx. So here we'll write differentiating with respect to x, differentiating both sides with respect to x, means d by dx of y is d by dx of t to the power 5. One thing I'll tell you here, I think this is the time you can understand it now, because when I say that d by dx of y, and then next time I write dy over dx, are the same thing, because this is again the function of, this is y. How can we differentiate y with respect to x? If it is not a function of x, then what will happen? Then again here also we have to make the chain rule. How? So what I do, that dy y, I change the order, d by dy like this, d by dx, this is my y, and then I write dy by dx, because I do not know whether y is related to x. Suppose if it is y is related to x, then the dy, because it is y, so I can differentiate with respect to y, and I can make the chain dy by dx. So, and since y is just y, so d by dy this will become 1. Same way here you'll have d by dt, t to the power 5 into dt over dx. Now dy over dy will become 1, so this is just dy by dx. Now d by dt of t to the power 5, and then here you see d by dx of, what is t? T is tan ax square plus b. So just let me clear the screen, I'll be writing it there. So I write the remaining part here properly. So this becomes dy by dx. I'm not differentiating, I'm just properly placing this nicely. So this is d by dt, t to the power 5. So this is, we have to differentiate t to the power 5 with respect to t. There is no problem, because d by dx of x to the power n is n x to the power n minus 1. So d by dt of t to the power n will become n t to the power n minus 1. And we have dt by dx, so we can write d by dx, and at the place of t here you can write what we have assumed, the tan ax square plus b. So d by dx of tan ax square plus b. Now you see that we have the formula, that is d by dx of tan x for sec square x. We don't have the formula for d by dx of tan ax square plus b. So again we need to make one more substitution for this also. So we say that this is d by dx of, I take this one as suppose r. So this will become tan r, and this will become d by dt of t to the power 5. Now again d by dx of r, that is not good, so we need to make it d by dr tan r into dr by dx, and this is again d by dt t to the power 5. Again d by dt t to the power 5, d by dr tan r, this is also in the proper sequence. And we have assumed tan r, means we have taken r as ax square plus b. So this becomes d by dx and ax square plus b. Now all of them are three different functions. This is the function of t, and we have to differentiate with respect to t. This is the function of r, we have to differentiate it with respect to r. This is the function of x, and we have to differentiate it with respect to x. There is no problem now. So we can write this as 5 t to the power 4. d by dr of tan r, d by dx of tan x is sec square x. So d by dr of tan r is sec square r. So this is sec square r. Now this is the sum of two functions, ax square plus b. Differentiation of x square is 2x, where a is constant, so this is 2ax, and this is constant, so it is 2ax. So this is 2ax. Now I write it nicely at one place. So this is 5 here and 2 here. This becomes 10ax. At the place of t we can write, this is my t. So this will become, this is, oh sorry, this is 5t to the power 4. So this will become 10 to the power 4 ax square plus b, and then the sec square r, so which is sec square r, that is x square plus b. This is your dy by dx. This is called method of substitution. So the target of the method of substitution is that you have the list of 10-12 handful of the formulas, and you have to substitute it properly, so that from this form this can go to the basic form, and there, just like this one, tan x, so this is tan something, so I just made something so that it's become tan x. So it means the from the difficult structure we have to make a suitable substitution so that we can get the form very much like the previous basic forms which we call as a formula. I think after practice and some perseverance with the concentration dedication, you can overcome these little difficulties. Thank you very much. Just keep learning.